From the Oregon State University Extension Service, this is Pollination, a podcast that tells the stories of researchers, land managers, and concerned citizens making bold strides to improve the health of pollinators. I'm your host, Dr. Adoni Melathopoulos, Assistant Professor in Pollinator Health in the Department of Horticulture. If you're interested in crop pollination, one of the first things you're going to do is go to your local extension office, and there'll be some kind of an extension document outlining how many honeybee colonies you'll need per acre to sufficiently stock the field to get full pollination. Now, this seems on first glance a straightforward proposition, but as my next guest points out, it's strongly dependent on the landscape where those colonies are being put. Maxime Eeraerts is a postdoctoral fellow in the Department of Environment in Ghent University in Belgium. You will remember him from previous episodes when he was at Washington State University and then at Michigan State University, where he was working on a large project, and we've got a number of podcasts dedicated to this project to come up with a pollination planner for blueberry crops so that a grower can look at their field and she or he can determine how many colonies they might need, when they need to arrive, and really maximize their profits through pollination. So in this episode, we're going to hear about a brand new paper that Maxime published from his work when he was here in North America, looking at how to assess honeybee colonies at the landscape level and why that's important. This week on Pollination. Welcome back to Pollination, Dr. Eeraerts.
Yeah, hello, Anthony. It's nice to be back.
You have a wonderful new paper. I'm so excited to have read it this morning. I was looking through it, and in the beginning of the paper, it raises these two terms that I think many people who work in ecology know about, but I think our listeners may not know about them. The terms are semi-natural habitat is the one term, and the second one is mass flowering crop. Now, can you describe each of these, and how have ecologists considered the relationship between them when it comes to managed and wild bees?
Yeah, thanks. That's a really good question to start with. So the first term, semi-natural habitats. So it's semi-natural. It comes from, in temperate climates. Most of the habitats in like Western Europe in total, and also Northern America, and definitely the east part of America, has been managed and altered by humans. So therefore, it's semi-natural. And semi-natural habitat is a bulk term for every habitat type that's kind of natural and that provides floral resources and nesting resources for bees or other pollinators. And this can be forest, extensive natural grassland, shrubland, hedgerows, wetlands, and those marshes as well. So this is then semi-natural habitat.
So it's something that's not currently under cultivation. I imagine that's maybe one way to think about it. Okay.
Yes. So no pesticides, no fertilizers. It can be managed, for instance, for timber or grazing, extensive grazing, hunting, etc. But it's mainly that it's considered as natural or semi-natural.
Okay. I can imagine. I'm just thinking, in my mind, I'm looking at a blueberry field, and there may be a little in the corner. There's a wet spot, and they've left the prunus, the shrubs, and everything to sort of grow. And maybe there's a quarter of an acre in the corner there. That's kind of what you're talking about.
Yeah, and also bigger parts, but also it goes from very small patches to really big habitat patches. And indeed, in agricultural landscapes, you often find these little patches of shrublands and wetlands and creeks.
Well, what about this other category? So if that's one thing, semi-natural habitat, all of those things, it encompasses all of those kinds of landscapes. What's a mass flowering crop?
Yeah, mass flowering crops are a type of crop that provide flowers that are of interest for bees and other pollinators, because they can find food there, nectar and pollen. The mass part of the term comes from the fact that, for instance, in blueberry, but also in apple and oilseed rape, the flowers, they come and go, and when they are there in the blooming period, it's like a massive amount of flowers. So it's a massive abundance of floral resources, and we contrast this with crops that do not provide these resources, like more forage crops or
I was thinking here in the Pacific Northwest, one would think of like grass seed as a mass crop, but not a flowering crop.
Yeah, indeed. It has flowers, of course, but they are not of interest for bees. The mass flowering crop definitely is a term that very much comes from pollinator research, at least as far as I know.
And so how do ecologists think about the relationship between these two when it comes to bees, either maybe managed or wild bees? Or have they not really thought about these two things in concert? Tell us a little bit about that.
Yeah, definitely for the wild bees, there have been a lot of studies that look at semi-natural habitat and see like both the composition, so more or less semi-natural habitat, but also the configuration, so smaller patches, bigger patches, well-connected patches with less well-connected patches, and these proportions of natural habitat and their influence on wild pollinator populations, and also wild pollinator reproduction and diversity. And then more recently, more studies have also been looking at mass flowering crops, because if you have these mass flowering crops in your landscape to a certain extent, they can provide resources that are of use to support bees as well. At least during the 1 or 2 or 3 weeks that they are flowering, these fields can really boost or enhance pollinator populations. The main conclusion regarding those mass flowering crops as well is that if the flowering period is over and if the landscape has too much percentages in area-wise then of these mass flowering crops, that they can be that they can cause a resource bottleneck in those landscapes, whereby the pollinators don't have sufficient resources in time. And they have also been looking at how the trade-offs between natural habitat and mass flowering crops, and how different pollinators prefer certain habitat types. And when it comes to the
go ahead, Maxime.
Yeah, when it comes to the managed bees, most of the research has been looking at solitary bees that nest in trap nests, like mason bees and Mikakyla bees, so leafcutter bees, and also bumblebees, because these are easy to manipulate and to test the abundance and reproductive output in these landscapes. And often these studies, they include counts of honeybees, but they're not really focused on. Yeah, the studies the studies don't always focus on honeybees, but they still include it as a measurement. And then when they look for effects of natural habitat of moss flowering crops on honeybee abundance, then it's often the results are very mixed because the studies are not designed for honeybees, because honeybees they're a domesticated bee. And if humans don't put these bees into the landscape, then they are not there. So that there's a very important human aspect there. And also the foraging range of the honeybee is a lot bigger or greater compared to that of bumblebees and mason bees and other solitary bees. So the landscape scale at which you would want to study effects on honeybees is a lot greater compared to that of the wild bees. So this in part explains why studies are very mixed when it comes to landscape effects on honeybee abundance.
Oh, okay. Well, that's great. So if I could just summarize that. So I imagine for wild bees, one could imagine a relationship where just mass flowering crops may be detrimental to the wild bees because they, as you mentioned, there'd be this pulse of resources and nothing. So some kind of balance between semi-natural habitat and mass flowering crops, one would imagine would be better for wild bees. But I imagine for honeybees specifically, if you had too much semi-natural habitat, maybe the bees won't go to the crop they're supposed to pollinate. But what you've said here is that there really hasn't been a study designed to answer the question for the largest kind of bulk of managed pollinators, the honeybees. That there's been a gap so far in terms of research that's focused on that question.
Yeah. Definitely. Definitely.
And I suppose that's why some of the results that people have had, because the research hasn't really been designed for that question, haven't been conclusive.
Yeah, the results are, if you, for instance, take 20 studies that look at those relationships, you find no effect, a positive effect, a negative effect, all sorts of inconclusive effects or results.
Well, let me shift gears just slightly. I want to go from the perspective of a grower, because this research was part of a ongoing USDA SCRI grant led by Rufus Isaac, and you did a lot of this work while you were working in Lisa DeVetter's lab at Washington State University, and where Dr. DeVetter really focuses on growers and trying to serve growers. And I wondered, how do growers think about, how many colonies they need in terms of semi-natural habitat and mass flowering crops? Or do they think about it in these terms, or are they using other criteria? What's the grower's perspective when they say, I need 100 colonies? Do they think in relation to these terms currently, or are they thinking in some other way?
My experience here is that growers mainly follow hive density recommendations, which are tailored to the field level, and they follow these recommendations that are provided by extension offices. So 4 hives per hectare, for instance, or per acre. And a lot of farmers or growers, they follow the recommendations, some don't. But growers also have their own experience and know more or less, like last year I had this amount which was recommended, and I want a bit more or I want a bit less based on their experience of the yield in each field. So they mainly think at a field scale or a farm scale, based on recommendations coming from extension, and then this is then leveraged with their own experiences, and they don't really think of it as like, oh, I have this landscape with a lot of semi-natural habitat, or this landscape with a lot of blueberries. I'm gonna alter it that way or decide on that.
Oh, so they may be a farm, like you may have two farms, one in the middle of nowhere, surrounded by semi-natural habitat, but that's a 10-acre farm. And then you may have another farm that's 10 acres in amongst lots of other blueberries. And they're following the extension recommendation and they're using the same number of colonies, but they're not the context of how much other mass flowering crop blueberry is in relation to them, or how much semi-natural habitat is in relation to them. That's really not something that has been worked out so that it doesn't come into their decision making at present.
Mm-hmm. It depends, of course. Some farmers are more aware and convinced of the research regarding wild pollinators, and then they look at the landscape a little bit, but in general it's more indeed the recommendations, and then how farmers or growers have experienced the link between density and yield in the previous years. Sometimes something that we also saw in Washington is that there's some kind of a neighbor effect that's some growers know, okay, my neighbor is stocking low, so in these fields that are neighboring that field, I'm stocking higher, and that is also something that we see. So that's more a social dynamic than a real landscape perspective.
But it's interesting because in some ways growers may know, like at this neighbor effect, they know that at the landscape level, there's enough colonies. They don't know the exact relationships, but they have a sense that there's enough colonies in this landscape. And so they maybe not order as many colonies because they know their neighbor has such large numbers. And in contrast, there are growers who know that there's wild pollinators in semi-natural habitat. They don't know the exact relationship, but they adjust according, to a kind of like a common sense rather than a, really kind of worked out. Okay. That's excellent. That's great. And I imagine, this research is, I think, has been designed to try and put some numbers on what these relationships are so that growers can kind of start to think about stocking density of honeybees in relation to these landscape parameters. Can you tell us what your research objectives are and your approach to trying to characterize or test these objectives?
Yeah, so the main research question of this study was how can we explain variation in honeybee visitation in different fields when we look at the different parameters that are highly likely to be relevant. And the first parameter here is the density of hives in a field or a farm. So this is actually what a farmer decides to put in the field. This can be 2 hives per acre or 10 hives per acre. There's a great variation in this aspect. Then another parameter was the number of hives in the surrounding landscape. And here we mapped the hives in a radius of 1 kilometer around our studies, around each study site. And for this, we went to each blueberry field in Washington in that radius and walked the perimeter and mapped the hives. And another parameter then is semi-natural habitat. So we also mapped the amount of semi-natural habitat around each study site. And in that way, we also then during mid-bloom of Duke, we surveyed pollinators, so both wild pollinators, but definitely also honeybees by catching them with a net when they visit flowers. And the nice thing about Washington is that you only have at least the Pacific Northwest side of Washington, so Skagit and Whatcom County, that over there you only have blueberry and raspberry as moss flowering crops. And sometimes the blooming period overlaps, but in 2021, they did not overlap. So we were 100% sure that during mid-bloom of Duke, all the blueberry fields in the surrounding landscape, also for other cultivars of blueberry, that they were fully stocked. Because we also did the hive mapping during mid-bloom of Duke, so we were really sure that there were no other hives, for instance, in raspberry, and we were at the full stocking density of blueberry at that time for the year. And then we compared or tried to look for the best, the model that best explains the variation in honeybee visitation with all these parameters in consideration. And here we found then that it's mainly the variation in hives in the landscape that describes the variation in honeybee visitation in the fields best, and not natural habitat, and also not the field level densities that the farmers put out.
Oh, really? So the grower who that you were thinking about earlier, the grower who thinks that, it's not how many colonies I put on the edge of my field, but the number of colonies in the area that matters. Mm-hmm. They're right. So you've noticed that it's not, how many colonies are directly adjacent to the field, but really what scale are we talking about for a grower who's trying to think about where this relationship kicks in? What kind of scales are we talking about?
The 1 kilometer scale.
Okay, so 1 kilometer, what happens if you shrink that down or make it larger? That the relationship is not there?
I don't know. We just looked at what scale is best explains the variation, and within that scale, we then looked at what variable is explaining our variation best.
Okay, so the most explanatory scale is a kilometer, mm-hmm. and so and the other thing that you mentioned is that the semi-natural habitat did not seem to when you looked at the number of bees that were visiting the blueberry flowers, and you looked at the number of colonies in that 1 kilometer radius, that seemed to describe how many bees were there. But how about the amount of semi-natural habitat? Did that describe how many? You said that did not describe the number of honeybees. Okay.
No, that did not impact the honeybees. And I think from the analysis that natural habitat also by itself at the different scales, it did not really impact the variation of honeybees.
I suppose this goes contrary to something that I've heard from growers who often have said that, if I have a lot of, flowering maple close by, that mm-hmm. this is going to impact the visits on my field. But this is not what you saw.
No. No, and of course, I think every hive has a requirement of pollen and diverse pollen. And every colony will go out and forage for that pollen because the queen needs that in order to feed their larvae and the brood. So if you have, for instance, a crop like blueberry, you can expect that all honeybees go to natural habitat or go to field margins for pollen because they're not really capable of getting pollen from blueberries, so we did not see a negative effect. But also, if you think about it very logically, it's probably better to have natural habitat close by because then the honeybees can get the pollen more easily.
Well, I remember somewhere in the paper you described that maybe it was something like only a sliver, a fraction of the honeybees were seen collecting pollen on the blueberries, so that.
Mm-hmm. Yeah, on average, I think it's 2 or 3%. So it's the blueberry requires dust pollination in order to release pollen, a lot of pollen, and honeybees are not able to do this dust pollination, so vibrating the flower. So yeah, compared to, for instance, cherry or apple, where honeybees can forage for both pollen and nectar, they can only forage efficiently on blueberry for nectar.
I interrupted you. You were set to say something else before I interrupted you. Do you remember what you were going to say?
What I was going to say.
Yeah. Before I cut in there.
Yeah, if you think about it logically, that sentence.
Oh yeah, that's right.
Yeah, if you think about it logically, your honeybees will spend more time foraging for pollen if a natural habitat is further away, and that will decrease their foraging.
Wait a second. So that's fascinating. So the idea is that if you didn't have semi-natural habitat, your bees still need pollen, and so they're going to be potentially spending less time on blueberry because they're taking these massively long trips to try and find the pollen.
Mm-hmm. Huh. Yeah, and it decreases their foraging efficiency, and it makes it might they might go to dandelion, but dandelion is often mowed, which I don't think is really good. But one thing is for sure, they will go to blueberry for pollen, for nectar. That's very obvious. So they will definitely visit blueberry, and if they then have to go 2 kilometers to find pollen, I think that decreases their foraging efficiency and might impact pollination as well.
So you did notice, though, that just coming right back to it, at this 1 kilometer radius, a number of colonies seem to describe the number of bees visiting the flowers. How did this impact yield? I imagine you saw variability in yield from the transects where there weren't very many honeybees to the transects where there were a lot of honeybees. Did this impact any of the yield parameters? Is having more bees on your blueberry flowers, I guess that's the premise, that's what we all assume, lead to higher productivity of berries?
We also measured pollination, and we found that we measured pollination by just the observing how many berries are formed and seeds are formed and berries are set by insects, and then adding also supplemental pollen by hand to a lot of branches to see what's the maximum pollination success of that field when it comes to fruit set, berry weight, and seed set. And here we found that in Washington, the gap between that maximum amount of pollination and the observed pollination by insects, that for fruit set and berry weight, that actually the gap is negligible. So they are well pollinated when it comes to fruit set and berry weight. But we did see for seed set that more honeybees on the flowers increase the number of seeds per berry. But this increase did not cascade or translate into an increasing weight of the berries.
I think we've discussed this on the podcast previously, that sometimes the seeds are really related to the size of the berry, but may not necessarily be so if the plant is limited in resources. It may not have the potential, I suppose, to fill that berry, even though the seeds are, strongly signaling. Is that one of the ways that you would interpret the fact that the more bees that you had didn't result in larger berries, but more seed set?
Yeah, that the resource limitation explanation might be fitting here indeed. But another thing might be that for Duke, for instance, 20 seeds might be enough to get really big berries, because the berries that we harvested often were very big. So in order to get these berries even bigger,
it may not be possible. Yeah. You've already reached the limit. Oh, that's an interesting way of putting it. Okay, thanks for explaining.
I'm not sure. Both the resource limitation and like 20 seeds might be enough. Could be at play. I'm not sure. We need more research to investigate that, I think. But definitely the berries that we harvested were often quite big. So.
Okay, so they didn't seem to be resource limited. So that second explanation may be in effect. But let's return back. We have neglected to talk about the wild bees. What were the wild bees that you saw in blueberry fields in Washington? What are what were you seeing?
A lot of bumblebees. I think in total we found 9 species of bumblebee, which is, for that region, is a lot, definitely considering the sampling intensity of our pollinator surveys. And then we also saw a lot of mining bees. And the mining bees, it's really nice to see. They vary a lot in size. You have smaller ones and bigger ones, and they carry a lot of pollen. So I can imagine they are like super, super important or efficient pollinators.
The one thing I just want to quickly mention, I think many of our listeners know that bumblebees buzz pollinate, but may not realize that many other bee taxa also get pollen out of these poricidal anthers. It's not just bumblebees that can effectively dislodge the pollen.
Yeah, and some solitary bees can also buzz pollinate. But for instance, osmia, there's one species of osmia that also gets pollen out of blueberry. But I cannot, in a different mechanism.
Okay.
Yeah,
all right.
I read it, I forgot it. But there are indeed different ways they can get pollen from it.
And I guess when we were talking about bumblebees, we're talking about queens. Blueberry is early in the season, and likely at that time they haven't had their first. They're just starting to make their broods, and okay.
And we saw a lot of species, but in most locations we saw very few specimens, and the abundance was very low, and often. Not often, but in I think 1/4 or 1/3 of the sites it was 0. So that's also an interesting observation to see that the natural habitat that is around in those landscapes still supports good bee populations. But when the fields get too big, these wild pollinators, they get diluted. And their actual pollination contribution is negligible or very much dependent on location.
Okay, so coming back to those parameters, the semi-natural habitat and mass flowering crop, I think I just heard you say that although there was remarkable diversity of, for example, bumblebees, the abundance was low. And so when you looked at the visits, the total number of visits on these transects, was there a response to the mass flowering crop? And conversely, with increasing amounts of semi-natural habitat, did this alter when you looked at the variation? Was it kind of coupled to more semi-natural habitat, like other researchers have found? Did you start to see more wild bee visits?
Yeah, the positive effect of natural habitat on wild bees was detected and observed. And at the same time, we also found that the negative effects, or the dilution effect of mass flowering crops, so more or bigger blueberry fields, is at play as well. So these natural habitats can still supply a lot of wild pollinators, but if the blueberry fields are too big, and if the farms are too big, then the abundance of these wild pollinators is too low because they get diluted in these big fields.
Okay, that makes sense. I wonder, just keep go. Sorry, Maxine. I think I took your pauses. But keep going.
Yeah. So yeah, I think the conclusion is that wild pollinators in Washington contribute very little to pollination of blueberry, but I think the potential is there when it comes to the diversity of the populations in the habitat. That it's possible to enhance them and to promote them if this would be desired.
Well, I imagine, especially with such diversity of bees in and around agricultural landscapes, it's quite remarkable. And I would, in terms of bee stewardship and sort of conservation and increasing biodiversity, some of these farms are really well positioned to, boast, that they have done stewardship. I think often, there's these programs around where, you have farms that promote that they're developing habitat for wild birds. They're in especially in that area where you have large bird migrations, a lot of those farms invest and really take pride in the fact that they're helping wild bird populations. I would hope that, given the finding that you have of the high diversity, that this might encourage some farmers just to invest a little bit on those semi-natural habitat.
Yeah, that would be one part of the solution. Another part, of course, is looking for the optimal hive density for your crop and sticking to that maximum hive density and not overstocking the fields in order to avoid competition of honeybees with wild bees or resource depletion of honeybees in landscapes. That's, I think, another part of the solution here, because sometimes the hive densities are in these landscapes are very, very, very high.
And so I think that, is it correct to say, at least in this study and in this variety, that maybe the benefits in terms of yield, were not manifest by increasing that landscape level? I mean, there's clearly an increased cost of getting the hive numbers up, but was there much evidence of, when you push that landscape level colony stocking rate, was there, I guess you already answered the question, the yield might not have been there.
Well, I also investigated the hive density in the landscape and its relation to yield, but I did not find any relation. But this year I collaborated a bit with Stan Chabert from University of Florida, and via him I learned this technique of segmented regression. And I think if we can apply that segmented regression technique, so it's looking for a linear regression up to a certain threshold, and behind this threshold, your relationship is non-linear, so it's not positive. I think if we apply this technique to this kind of data, then we can determine the number of hives in the landscape that is required, and where you see a yield benefit or a pollination benefit.
Oh, just to break this down for the listeners. So if you right now you're assuming but there may be a threshold. You mentioned this earlier, where
I think so.
Yeah, and if at that point a grower would know that any additional colonies they put in that landscape, may not be giving them any benefit. In contrast, it may have these negative effects on this wonderful bee diversity that they're supporting in their landscapes, and that one could maybe come to a better compromise between these two things.
Yeah, and I think with that statistical technique, I think we can use the data that we collected in Washington, but also in Oregon, in Michigan, and Florida, to test these relationships and to see also how that it is variable across states, because the landscape in Michigan and the landscape in Washington and Oregon and Florida is a lot different. But to really go to or try to use this threshold approach and based on that determine like this is the hive density beyond which, if you further increase, beyond which you don't see an added yield benefit, and recommend growers and perhaps even policymakers to stick to that maximum in order to also conserve wild pollinators. But that discussion will bring us very far, I think.
Well, this is fascinating, and it should, just to mention that you are working on some additional. This project is taking place not only in Washington, but also Michigan, Florida, and Oregon, and so there's a lot more data to come out of this. And the ultimate goal of this project is to give growers a tool, a planner, so that these kinds of decisions. I like the way that you put it in this podcast, that there's a kind of back of the envelope calculation that a grower in lieu of having better data and better models has to make sort of decisions. But this will really help that decision making when this project wraps up. There'll be better tools for growers to be able to really kind of consider what benefits, what the costs of what they're doing, and what are the larger benefits, both in terms of their farm profitability, but also in terms of stewardship they may be able to get.
Yeah, I think that's the goal.
Well, before we wrap up,
get there.
Yeah, before we wrap up, though, I do want to just quickly ask: you are now, the last time we talked to you, you were in Washington. Mm-hmm. Now you're in Belgium. Tell us a little bit about what you're doing there.
So I transitioned again to Belgium in November, and I'm now back at the University of Ghent, working at the lab of Chris Verheyen. That's a forest and nature management and forest and nature ecology lab. But I will still mainly focus on pollination and crop pollination, and also the well-being of pollinator populations in landscapes, both in agriculture, but I think we'll also try and look and study the benefit of urban gardens for pollinators, because in Belgium 10% at least in Flanders, so the northern part of Belgium, 10% of the land area is taken up by gardens. But then also, in addition to that, see how we can study these, similar to the blueberry projects, to see how we can study crop pollination and develop more targeted guidelines that benefit farmers and the yield, but also the pollinators. That's a bit more applied research.
That's wonderful. Well, if people haven't heard, there's a really great, just to showcase the diversity of Dr. Eeraerts' research interests. There's a wonderful podcast that we did with him earlier on managing solitary cavity nesting bees. So have a listen to that. So good luck on your next venture. Yeah. We are looking forward to hearing more about what you're up to. And thanks for, we're really, for those of you who are interested in this paper, it'll be linked in the show notes. Real fascinating read, and just more and more information coming to our blueberry growers to help them make decisions around pollination. So thank you so much for joining us again today.
Thanks for the invitation. It was a pleasure.
Thank you so much for listening. The show is produced by Quinn, Sin, and Neil, who's a student here at OSU in the New Media Communications program, and the show wouldn't even be possible without the support of the Oregon Legislature, the Foundation for Food and Agricultural Research, and Western SARE. Show notes with links mentioned on each episode are available on the website, which is at pollinationpodcast.oregonstate.edu. I also love hearing from you, and there's several ways to connect with me. The first one is you can visit the website and leave an episode-specific comment. You can suggest a future guest or topic, or ask a question that could be featured in a future episode. But you can do the same things on Twitter, Instagram, or Facebook by visiting the Oregon Bee Project. Thanks so much for listening, and see you next week.